if you check, this is the one kind of paper, use of MODIS satellite based aridity index to monitor drought condition. Again, this paper. So basically, when you work with the surface based aridity index, we need the two data set. Okay, so we need the two data set, basically surface reflectance data set and the surface temperature data set. Surface reflectance data set and also surface temperature data set. Two data set we need, and this type of data set we can easily get from the MODIS satellite imagery. Okay, it also provides MODIS satellite data. And you can see the MODIS satellite provide the better quality of longer continuous data set. MODIS product, okay. And you can easily, because we try to identify globally surface aridity index for the globally, so MODIS is very work well. And you can check this two dataset product name, okay, and it generated from the Terrain Aqua satellite. And you can see in this paper they are also used at the Google Earth Engine. And they are also used at the precipitation data also from the Tropical Rainfall Measurement Mission, TRMM. And you can see the formula about that satellite based aridity index, okay, and also calculate the diurnal, means LST day minus LST night temperature, this difference, okay, and this is the 1 minus r cos theta, and this is the formula about that reflectance value, okay, they are calculated in here. So I just use the same method and then try to develop this SAB, I mean this land surface temperature surface based aridity index. Okay, so this we need the two formula element, okay, delta TS and RS. Delta TS basically diurnal temperature, basically LST day minus LST night, okay, LST day maximum temperature minus LST night maximum temperature, this is the difference. And this RS basically it's a reflectance, so you can see 1 minus R S 0 cos theta C. So this is the formula about that. And here R basically you can see this type of this formula 0.160 R1. Okay, this formula we need to compute. So let's go try to use this type of things and then compute one code. So let's go. Okay, so these are final result. Okay, mainly after classification we find out that normal, so this type of white color we find out the normal, and this type of blue color dry sub humid region in the world, then green color indicating about the semi arid region, yellow is the arid region, and red is hyper arid. We find out the hyper arid region globally, we find out. So let's go try to explain how we can easily create this type of work, then you can get the better idea. So if you check, first of all, okay, this is the background. So background, if you want you can see basically without background we find out this type of world map, but if you want you can also add a background. Oh sorry, if you want you can also add a background. So just click on the, you can say background, so it added this type of black color or any color you can choose and take this type of background. So in this background we can also add the map. You can see this is the daytime land surface temperature, and also add the nighttime surface temperature, then difference between the daytime and nighttime. Then we also take the true color, basically reflectance, surface reflectance data, and further simply apply the formula and then get the result. So let's go try to explain the code. And I think what is the problem show? Okay, because it's a lot of data set for the whole world, so that's why it takes this type of problem. So let me run the code again. So first of all, if you check, this is the data MODIS, and from this data we can easily get the LST information. Okay, why is the MODIS LST? Yeah, dry and aqua. So this data set, it provides the reflectance value from the MODIS. Let me search for MODIS LST. So it provides the MODIS LSTD 1 kilometer, daytime land surface temperature, and we'll also find out that another one nighttime. Okay, nighttime. Okay, so from this data set we can easily get the two times, suppose nighttime and daytime temperature from here, and further we just simply compute the difference between the daytime and nighttime temperature. So now if we can get, so this is the data. So in this data we also use here the QC day. Okay, so QC, this is it's one kind of band. It also mainly quality measurement of the MODIS data. So QC, you can see daytime LST quality indicator QC, and we find out in the QC we find out some bit and bit number. If you check QC day bit max 0 to 1, mandatory QA flux. 0 basically LST produced good quality, okay, and not necessary to examine, and more detailed QA data for the 0. And one signal LST produced other quality, okay, not good quality, is other quality, recommended examination of the more detailed QA, okay. And as signal 2, LST not produced due to the cloud effect. So this is the another signal, LST not produced due to the cloud effect. And then if you check bit 2 to 3, okay, data quality flag 0 is a good data quality signal. Also you can say other quality data, TBD, different types of flag. 4 to 5 emissivity error, okay. You can 0 basically average emissivity error less than equal 0.01, okay. Another you can say other than the flag LST error flag. So this type of bit we also use to get the more better accurate result for LST, okay. Basically it's one kind of quality measurement, QC data, daytime quality indicator of LST. So now how we can use this type of band, I will try to explain that. Just a minute. Okay, so here we find out you can say QC day. After loading the data, we simply apply the create a function. Okay, this is our data set. So in this case we try to identify the surface based aridity index between this time period from 2000 to 2019. Okay, this is our time period, and then we just create a function. In this function we simply select the band of QC day, and in this case we get some bit. You can see some bit 0 to 1. Okay, here we find out that 0 basically good quality, 1 basically other quality, 2 basically not produce cloud, okay, 3 may not produce the others. So in this case we simply select this type of bit. You can see bit max 1, 0 basically good data, okay, just I put the 0. Then you can see bit max 2, this is another signal 2. Then you can see the bit max 3, okay, and average LST error, and update all of those. So it's one kind of filtering process, okay. QC day for the daytime quality attribute, and also QC night. So this is the nighttime quality attribute. So these two function we need to use to produce the more accurate LST data from MODIS LST dataset. Okay, so this is the two code. You can see this is the code basically LST day 1 kilometer. Okay, for this QC day function, and if you check, this is the another, this is the QC day function. Okay, QC day function, basically it's one kind of attribute. We can easily pixel quality attribute, we can get the more better imagery all of LST. Okay, so this two code LST day 1 kilometer. So this is the LST night 1 kilometer night temperature, and this is the daytime or for the QC day. So this is the function. So these two function, if you check, this is the function variable name, and this is the another function variable name. We simply connect with the LST day 1 kilometer and LST night 1 kilometer. So you can see for that I just call the data set and put the map function, put this function variable name, and select the LST day 1 kilometer and compute the average and multiply this function to reproject the pixel value and subtract this value to convert degree Celsius. Okay, Kelvin to degree Celsius. Same process, just I call my data set and call the QC data for night QC, basically marks night. This function is stored the QC night attribute and quality, and select the LST night 1 kilometer and compute the average. Same process, just multiply and convert into degree Celsius. So you find out this type of things, and further is simply compute the difference basically day temperature and night temperature, land surface temperature day and land surface temperature night. So simply compute this, subtract this function variable, subtract with land surface temperature night, this variable, and further is simply display the result. Okay, so you can see simply at the land surface temperature visualization and make a background dark blue color. So for that simply use this code. So make a background, so just put the e.image, then visualize and put the plated, you can put any color. So this is the hexacolor code of the dark blue for the cartographic effect. Okay, or then put the background. So now you can see when I open the background, it just show this type of background, it just display this type of background. Okay, not showing the map. So now from here you can easily get the daytime. Okay, this is the daytime temperature. Okay, and this is the nighttime temperature, and this type of data is the more accurate because we already filtering the QC data, QC daytime and QC nighttime. Always use the same code for filtering QC data, nighttime and daytime. And further you also compute the difference. Okay, basically subtract this daytime temperature minus nighttime temperature, then we can get that diurnal temperature, difference between the days and night time LST. Okay, so it display this type of things. Okay, but we also create the time series chart. So for that just call the data set, and this is the function. Basically it's help you to remove all of unnecessary pixel and ensure that good quality of your data. This is the function. Okay, and select the band name LST 1 kilometer, and also same for LST night 1 kilometer. And I want to make the time series chart from 2002 to 2019. This is my time period. So further I simply make the list, start year and in year to make the sequence, and then we create the time series chart. Okay, for the time series chart, ee.image collection from images, we just already defined the years, so we create a function. So we create the annual day time series chart and annual night time series chart. Okay, annual day and annual night time series chart of LST. So for that simply call the annual day and call the dataset day. Okay, dataset day stored all of image collection only for the dataset day. Basically it's come from here, dataset day, and filtered the yearly. So yearly just we filter. Same process, annual night, just call the dataset of night. It is stored in this variable dataset 9, and filter calendar range yearly, annually, and then annual day and compute the subtraction. We just simply calculate the difference. So just we put the difference all of those and return this band. Okay, LST day, advanced LST night, and also LST difference. So in this case, we just create the annual image collection, LST collection annual, and also create the bands. Okay, LST day annual time bands, then LST night annual bands, and also difference annual bands we create. So further this type of band I can use and also make the time series chart. Okay, further we simply create this type of function. So in this function we can define annual day, annual night, and also difference between the day and night, and all of annual day, annual night, and difference just return as a bands. So every year or annual from 2000 to 2019 I find out the annual bands. Suppose LST day, then LST night, and difference we find out the bands. And if you print this, then we find out the band name from this 20 years image collection. 20 years image collection, if you check, 3 bands. Okay, first band LST day, then second band LST night, and also RS we find out. Okay, if you check the property, this is the result for 2000 and up to 2019. Okay, so this is the process. We simply make this band, and you can see put the rename this type of difference. This is the difference. Okay, now this first part is done. Okay, first part is done. In this paper, if you check, we just cover this part, just delta TS. This temperature part is done. Okay, delta TS temperature part is done. So now we work with the RS, mainly reflectance value, and you can check for this formula. You just compute the R, then 1 minus R is 0 cos theta C, then we can get the RS, then simply divided TC and RS, then we can get the surface based aridity index. Further make the classification and identify the arid zone. Okay, and now if you check, okay, let me show. So this is the data, MODIS reflectance data. So we need the MODIS reflectance data set, and we filtered the data set between 2000 to 2019, and then we are just simply filter this data set to remove all of cloud or all of haze and get the very neat and clean MODIS composite. Okay, so if you can check, this is the code. So we always use the same code to removing the cloud. So we already know about that, how to remove the cloud and haze from the Landsat and Sentinel. Same process. Okay, so this is the state 1 kilometer. So basically this is the QA band or pixel quality attribute band for the MODIS reflectance dataset. So just I use it and then set the bit. Okay, so bit 10, bit 12, bit 2, and then simply update marks, and it set equal to 0 signal, which is indicating about the clear condition. So this is the function to mark the cloud from MODIS reflectance dataset. Okay, and this is my MODIS reflectance dataset stored in this variable. So just simply use the map function and connect this function variable name and select this type of band B1, B2, B3, B4, B6, B7. Okay, and also create the solar genth. Basically it's the degree unit. We also consider this band also, and compute the median and click with the study area, and further we create the composite B1, B4, and B3 bands and display the true color composite. Okay, so now it add the layer, so it's loading. So now we find out the whole world MODIS true color composite it generate from the MODIS reflectance value. I think it takes some time because it's covered the whole world. Okay, after that we also need to work with, okay, we need to compute a formula. If you check this, the formula, basically R formula. So from this collection, from this MODIS median collection, we just create from this image, we compute this equation. You can see this is the equation 1 minus 0.16 r1. So basically this equation, where is it? This equation, okay, 0.160 multiply r1 plus 0.291 multiply r2, okay, up to r7. Basically it's the different types of bands reflectance. R1 is the 1 band, 2 band, 3 band, 4 band, 5 band, 6 band, 5 and 7 bands. Okay, so this type of band simply multiply with this variable. Just these things will apply in here. I can see. And 1 minus, so this is the formula. Okay, 1 minus 1, you can see this is the 1, and then minus 0.106 multiply band 1 plus 0.291 multiply band 2, then 3, 4, 5 and 7. Okay, simply you use this formula, and you can see this is the cos 75 degree. Okay, just simply apply this formula. And now what is the r1? We define the r1. It's come from the reflectance surface reflectance band 01. So this is the band name. Multiply this value to reproject the scale value. So band 2, band 3, just define the band, and you can see what is the solar gene. It's not need to multiply because it's a degree unit. So simply select this band. Basically this is the G7. So in this formula you can see solar zenith, and rename it the RS. And finally you can see the difference image. Basically LST divided this RS, which I compute in here, RS image. So when I divide it, mainly we just compute this final formula, this formula, okay, del TS divided by RS. So then we can easily get the subsurface aridity index, surface based aridity index. It's computed, and further just make the classification. Okay, so if the value less than equal 0.015, so it's one class, then greater than this range it's another class. So based on the class we simply display. So you can see it also loaded the map. So I think it also better when you work with the research paper, you try to work with a continent. Suppose only work for the Africa region or South Asia region, okay, then it will be more better. We find out the better result from this, and you can also check some literature also. Then you can get very good quality paper you can also published using this concept. Okay, suppose you just work only for the South Asia or Middle East to identify sub aridity index, okay, surface based aridity index. Okay, and this apply this type of things, and this aridity index we can also connect with the others parameter also. Suppose in this paper they are also connect with the precipitation, okay, TRMM data, tropical rainfall, this type of data, they also connect with that and also published. So you can also try to do this type of things. Suppose when you work, you just if you want you can also choose only for a specific country boundary also. Okay, suppose not for the whole world or whole continent. Suppose you want to observe only for the where we find out the more variation of aridity, you just try to choose this type of countries, only choose this type of countries and also work for the aridity index to identify. So this is the image we find out, okay, for the whole world reflectance, and further just make the classification. So then we find out this the final map for aridity index in uh, between this time period, and then we just create the time series chart of that. So it's loading. Just a minute. It's loading. Mhm. It's a whole world, so that's why it take more time to produce the data. But when you work for your research work, then try to use only for specific countries, or you can also use only for the subcontinent area. Then it will be more better. I think it takes some time. Okay, so we find out this type of classification. Okay. So in the meanwhile, I'll try to discuss about the another topic. Okay, so when it will be show the result, then I'll try to discuss. Okay, so now time series chart. For the time series chart, so in this case, I want to observe time period from 2000 to 2019. So you can also get the 2025 or 24. This type of data set is also available. No problem, you can also use. So for the time series chart, just make the list of sequence. Okay, and then simply apply. So in this case, I want to make the time series chart for surface based aridity index time series chart I want to create. So now all of those which I compute this type of things, I just convert as a bands. I need to create a bands. So for that you can see, just we make a bands. Basically we create the annual time series chart of surface base aridity index. So for that you can see, just I create take a years and then create a function. In this function we simply call our collection. Okay, this collection just simply filter annually, year by year, and compute the average and clip with the study area. Okay, and also call the LST collection. Okay, so LST collection we also take the yearly and clip with the study area. Then you can see, just apply this formula. Okay, 1 minus 0.160. So this is the formula. Simply compute and rename it RS. Then simply apply the SABI formula. Basically image LST